All right, hi Julia again. I powered up. Look, I got 5%, so much better. I switched locations. So I want to talk about number 5, and I'm going to show you an example problem like this. This is called factoring using quadratic techniques. So factoring using quadratic techniques. And what I'm going to do is I'm going to use Desmos again. Use Desmos all the time. When you get to pre-calc next year, this is like your best friend. It's going to give you a quick image, quicker probably than you can type it into your graphing calculator, and you can make some really good analyzations. And it's a great way to check your work. So Desmos, Desmos, Desmos every time you can. All right. So let's take a look at this function. What I'm going to put in f parentheses x. So this is the one I'm going to look at that has a relationship to the one you're going to do. Bear with me. Fourth minus 9x squared, and then plus 4. All right, so let's take a look at this. Here's your function, 2x to the 4th. If you want to write it down, you can. If you just want to follow along, that's good too. Minus 9x squared plus 4. And I want to take a look specifically at what this function looks like. So notice how it is. Do you remember that degree question? I'm going to ask you to think about this before I point it out. This function has a degree of 4, because the highest power in this function is 4. And what that tells you is there's going to be 4 identifiable zeros. Now, your zeros could be real or they could be imaginary. So if they're real, they're going to be x-intercepts. And in this case, because of the fact that it does work out that all of my solutions are real, notice I have 1, 2, 3, 4 x-intercepts. Okay, so degree of 4, 4 solutions. They may or may not be real, and we're going to look at what it looks like when they're not real in a moment. But for now, we're going to look at a function with all 4 real intercepts. And some of them are nice and easy. Look, this guy's a negative 2, 0. Ooh, love that. An integer value. This one's positive 2, 0. That's excellent. These are a little bit more odd, right? More, I guess not even odd. They're irrational. But Desmos is rounding to the nearest thousandths place, but 0.707. So there's a way to actually figure out what these zeros are algebraically, and that's what number 5 is asking you to do. So I'm going to look at this function. I ran out of eraser, so I had to scribble. Please don't judge. So this is a 4th, right? So we can use something we call quadratic techniques. Quadratic techniques. And basically what that means is pretend like this was a quadratic. This was a power of 2. How would you factor this if it was a power of 2? And it depends on the person. Some kids can do it by inspection, but I would suggest trying to do it by grouping. And the way grouping works is you take your the first term and the last term, and you're going to multiply them together. Not really the term, really the coefficient. So I'm going to take 2, I'm going to multiply it by 4, I get 8. And then I find the factors of 8 that are going to combine together to make 9. So factors of 8 are 2 and 4, and then 1 and 8. And if I want to combine to make negative 9, a negative 1 and a negative 8 would do that. And a negative 1 times a negative 8 does indeed give me a positive 8. So now what I'm going to do is I'm going to take my function, I'm going to change my middle term into a 2x to the 4th. So I'm maintaining this first piece. Minus 1x squared minus 8x squared, and then plus 4. And it doesn't matter the order in which you put these terms, it's going to work out the same. And then I use a strategy of grouping to be able to figure out what my factors are. So Here, there's a common factor of an x squared, so I'm going to pull that out. I have 2x squared minus 1. And then over here, there seems to be a common factor of 4. But notice how there's a leading minus. I'm going to actually take out a minus 4. And I get the exact same factor. And you actually force that to happen when you're grouping. So now, do you know what your factors are? Do you remember this from Algebra 1? F of x would be 2x squared minus 1, because that's my common factor, right? I'm almost like factoring that out, times an x squared minus 4. Now remember what our goal was. It's to kind of figure out what the solutions are. Well, if this is 0, that would give me an x-intercept, right? Your x-intercept is where your function equals 0. So if I want my function to equal 0, right, then I either need to make this part of the expression equal 0 or this part of the expression to equal 0. It's called the zero product property. Let me know if you're unfamiliar with that. But here we go. I'm going to actually do this one first because it's easier. So I have x squared minus 4 equals 0. I can balance. I can use the strategy of balancing to solve. Square root, x should equal, don't forget, both a positive and a negative 2. Which is what we see in our graph, both a positive 2 and a negative 2. So I betcha this is where that 0.07 comes from. 2x squared minus 1 equals 0. Add 1, add 1. 2x squared equals 1. Divide by 2, divide by 2. X squared equals a half. And then, boop, square root, square root. Guess what the square root of 1/2 is? About plus or minus 0.707. Isn't that interesting? And that's where we get those irrational zeros. All right, so hopefully that's going to be okay for you for number 5. That's kind of the example problem that goes along with that. I'm going to journey on to number 6.